So in this video, we're going to take what we learned about symbolizing connectives in the last video to start symbolizing entire sentences. To analyze English language or any natural language arguments in which validity depends on truth functional connections between sentences, let lower cases p, q, r, s, and so on denote simple sentences, like Plato is wise or my cat likes catnip. Let the symbols, the arrow, ampersand, wedge, tilde, and double arrow, denote the truth functional connectives we discussed in the last video. So, for example, if P stands for Piper is a poet, and Q stands for Quincy is a poet, then this means if Piper is a poet, then Quincy is a poet. This means Piper is a poet and Quincy is a poet. And this means Quincy is not a poet. Sometimes the sentences symbolized will be more complex. For example, how would one say that if Piper is a poet, then either Quincy is a poet or Raina is a musician? How would we put that into our symbolic language? Okay, so let's take a look at this sentence. If Piper is a poet, then either Quincy is a poet or Raina is a musician. Let's let P stand for Piper is a poet, Q for Quincy is a poet, and R for Raina is a musician. Notice that in this example we've got two connectives. We've got the if, then, but also an or. So when we turn this into symbols, we're going to need to have both the arrow and the wedge, as well as all three of our simple sentence letters. But there's a problem here. This is ambiguous. It could mean two different things. First of all, it could mean if Piper is a poet, then either Quincy is a poet or Raina is a musician. This becomes the antecedent, and all of this, the rest of it, becomes the consequent. What we're saying is that if Piper is a poet, then one or the other is the case. But what about this? If Piper is a poet, then Quincy is a poet, or Raina is a musician. By dropping the either and moving the comma, we could see that this sentence says something different. It says either Raina is a musician or there's a conditional relationship between Piper being a poet and Quincy being a poet. But this, on its own, doesn't tell us which interpretation to go with. The way we fix this problem is by putting in parentheses. The sentence we were working with was this first one, so in order to make sure that our sentence in symbols says this first one, we're going to put parentheses around the P or R part. Now, how does this fix the problem? The way to think about this is to think about operations in math. Just as you put parentheses around the operations that you want to start with, so we're going to put parentheses around the operations we want to look at first. So what this shows us is that this comes together as a package first in relationship to the arrow. And that's what this first interpretation tells us. It says something about if Piper is the poet, then it tells us something about all of this. By putting this in parentheses, we make the entire section subject to following the arrow. So, on this reading, we end up with this sentence, whereas before, when there was no parentheses, we couldn't tell which one of the two we were going with. So just like in math, we can use parentheses to show which operations to look at first. The connective outside of all parentheses is called the main connective, because it's the central connective that we look at last. Let's take a look at another example. Let's go with the sentence, neither rain nor sleet can keep the postman away, but only Superman could deliver mail in this snowstorm. This is an example taken from your book. Well, to start, let's pick out what the simple sentences are. It's a little tricky to tell exactly what they are because you've got this rain nor sleet clause. Really what you've got is this simple sentence, rain can keep the postman away, and the simple sentence, sleet can keep the postman away, plus this third one, Superman could deliver mail in this snowstorm. So let's make P, rain can keep the postman away, Q, sleet can keep the postman away, and R, only Superman could deliver mail in this snowstorm. The next thing we need to note are what the connectives are. We've got the but, which is another connective that can be used for conjunction. Just like you say if A, just like you can say A and B, you can also say A but B, and it means the same thing. The connotation of but is different, but the logical equivalence is the same. Now, what's going on with neither nor? We've got both an either or function, but also a not function. So what we actually have here are three connectives: the not connective, the disjunction connective, and the conjunction connective. So this is going to be a more complicated example. Let's start by figuring out what the main connective is. The main connective is going to be but. The thing that tips us onto this is where the comma is. It's separating the sentence into two large halves, and the but is what's bringing the two together. That's why we know it'll be the main connective. Okay, so because this sentence is more complex, it'll be easier if we break it down into parts. Let's take this first part. Just the neither rain nor sleet can keep the postman away. So now we're working with just two simple sentences, P and Q, and two connectives, the not connective and the or the disjunction connective. It'll be easier if we separate the not from the or. So let's try rephrasing this to it is not the case that either rain can keep the postman away or that sleet can keep the postman away. Note, this is saying the same thing. If we say neither rain nor sleet can keep the postman away, that means the same thing as it's not the case that either rain can keep the postman away or that sleet can keep the postman away. And now it becomes a lot easier to see what to do with our P and Q. What we've got is a not out front and then our P and Q inside. What we're saying is it's not the case that rain can keep the postman out of the way, and it's also not the case that sleet can. So the way the tilde works is if you put parentheses around something and a tilde right in front of a parenthesis, it will apply to everything inside the parentheses. So we've negated all of this, which is exactly what happens when you say it's not the case that either rain can keep the postman away or that sleet can keep the postman away. Okay, so now that we've got this first part of the sentence done, we've really done the hard work already. Now we add back in, but only Superman can deliver mail in this snowstorm. And with that being R, we just add and R onto the end. So this here is the appropriate way to turn into symbols this sentence. Before moving on from this example, let's look at one more thing about this neither rain nor sleet can keep the postman away business. We translated that into it is not the case that either rain can keep the postman away or sleet can keep the postman away. And that we translated into symbols as not the case that P or Q. But we could have also translated neither rain nor sleet can keep the postman away into rain cannot keep the postman away and sleet cannot keep the postman away. They all say the same thing, that neither rain nor sleet is sufficient to keep away the postman. But this sentence gets translated as not P and not Q. What's going on here? Well, let's take a look at the truth tables for both of these sentence forms. Here we've got the truth conditions for not P or Q. We start by looking at the different ways in which P and Q can be true and false. And then, like we did with disjunction, we see that, okay, when we put, say, P or Q, this is false in all circumstances except the one in which both of these are false. But then if we're saying not that, we negate this, the opposite truth conditions hold. This will be false in all circumstances where this is true, which of course is in all instances except the last. So the truth conditions for this look like this. These turn out to be exactly the same truth conditions for not P and not Q. When this sort of relationship between the truth values of two sentence forms hold, the forms are said to be logically equivalent. Thus, this form, not P or Q, and this form, not P and not Q, are logically equivalent. Why am I calling them sentence forms? Well, that's because these symbols, P or Q, could stand for any old thing. We're working with form again and not content when we look at those sets of symbols and talk about their relationships. The logical equivalence of not P and not Q and not P or Q is an example of De Morgan's laws, named after Augustus De Morgan, who pointed out important similarities between some aspect of logic and ordinary algebra. He in fact pointed out these four equivalences. This one here is the one we already looked at, but if you were to do tables for any of the other three, like we did with this one, you'd see that the truth conditions turn out to be logically equivalent. Alright, so in the next video we're going to move on to start making some applications from some of the stuff we covered in this video and the last one.